Next is gonna be about 2D geometric transformation. Firstly, we're gonna look at translation. So 2D translation. For example, we have a point P here, and we want to translate this point P to P prime. So how can we do that? So P prime have the coordinate is x prime and y prime. So x prime can be determined by x plus t, where t is this distance along x axis, and y prime is equal to 1 plus dy, where ty is actually the distance from p to p prime along y axis. So that is normal notation, but we can also do it as a matrix. So if we define P as a vector P, then, and we define the translation vector is T, which is a vector with two elements Tx and Ty. Then we have P prime is just P plus T. So we have the formula for 2D translation looks like this. So let's have an example in Python. Okay. So we got an example in Python here. For example, if we let's say we use matrix notation. So firstly, we're gonna need to import Numpy. Yep. Then we define x and y. Then we define a vector called P with two elements x and y. Then we define Tx and Ty. Then we define a translation vector which is T with two elements Tx and Ty. Then now we just apply the formula. P prime is actually P plus T, and we run it, and we have, so P prime is 25, 15, because we just add 20 plus 5 is 25, 10 plus 5 is 15. So that is using matrix notation, but we can also easily use this formula. So because we have x and y is 20, we also have Tx and Ty is 5 and 5, and xp, x prime is just equal to x and tx, y prime is just equal to y and tx, ty, and we have the same result, 25, 25, and 25, 25. So we can use matrix notation, or we can use normal notation to do the translation, but matrix notation will be faster if we have more data, if we have big data. And that's it for 2D geometric translation from P to P prime using translation matrix. Okay, so that is the translation. It's called translation vector, but it can be a matrix as well.